Hello guys, today we're going to be talking about the Festo SMS series, Simplified Motion Series. And this series is made up of quite a few different axis or type codes. We have ELGS, which is what I'm going to be showing in this particular video, the ELGS ball screw, the tooth belt, and there's quite a few other axes that are in this series. EGSS, EPS, PCS, ERMS, and the list goes on. And the specific one we're going to be using in my project is this ELGS ball screw. The sample code, the functionality, everything is identical between the whole series. And this is an IO-Link product, and we're going to be connecting this IO-Link product to a 5032-8IOL series, ArmorBlock series from Rockwell or from Allen Bradley. And if we look at the topology from a normal view, we've got a GuardLogix PLC, and we're communicating over Ethernet IP to the IO-Link master from Allen Bradley, and then we have the port connected as IO-Link to the device, to the Festo SMS product. The motor itself on this product is normally called EMCS-ST, and this particular video is going to be talking about backup storage or data storage, and in this project we're going to enable the backup restore option for the device, so that when a new manufacturing default device is connected to replace the existing device, the IO-Link master will write its existing configuration and all the parameters that are part of the data storage to the device. So let's get into this. I'm going to start off with a project, and the project is going to be the 5069 L310 GuardLogix 5380. It's important to understand that the IO-Link master, the 5032-8IOL, is only compatible with certain software. It's version 35 and higher, and then additionally there's a real limitation on which PLCs are able to manage this IO-Link master. And if you go and you download the user manual on this topic, so in my case I'm using this 5032 UM001C-EMP November 2024, and we'll see here that the limitations are version 35, and these are the processors for the IO-Link compatibility. And this one right here, I'm in here somewhere. Anyway, I'm in this 5380 right here. Move this out of the way, and I'm starting off with the oldest version possible, so that anything you do, you can simply open it up and it'll open with the project with being compatible. I've got a dual axis or dual IP mode. I've configured it for linear, and that's about it. So I've added my project. Everything else is basic. I've got some basic code in here, which I may or may not include in my sample code, and let's go. So the next compatibility feature that we need to look at is, again, related to the 5032-8IL series. And if you go to the website and we go to the multi-product selector and you type in 5032-8IL, you get to the point where you have these downloads. So right now, this particular product here is using the add-on profile 2.012, and if you go to compare, it talks about what's compatible features, anomalies, so on and so forth. And you can also download the firmware. So if you go backwards, you will eventually get to this drop-down window where you're downloading the add-on profile version 2.02.02, and you're downloading the firmware. So if you want to see what I'm pointing at here, so we're downloading the firmware 2.012, and we're downloading add-on profile. So I've installed both. So I've installed the add-on profile into the Logix software, and I have installed the firmware into the 8IOL. If you want to know how to download the firmware, you use Control Flash or Control Flash Plus to download the firmware and go from there. And so moving along, we get to our project, and the first thing that we're going to do is we're going to add a new module. I might pause the video here and there when Rockwell is slow, just to keep the video moving along. So in my case, I'm using this particular device. So I'm going to add this. And we have to start configuring it. I'm going to call this IOL1 for IO-Link number 1. I'm going to go on the private network. I'm going to use IP address 130. Under the module definition, you need to match this to your device. And as I said previously, we're using 2.012, and we're going to configure it for data in Ethernet status. And I'm going to configure channel 0 for IO-Link, and I'm going to simply, for this project, I'm going to disable everything else. So, okay, I'm going to hit OK, accept the definition change. So now we have IO-Link, and we have the 130, we have the 2012 Series A. Under connection, I'm going to leave the default for now, and let's see if we have anything else we need to configure. Okay, that's it. So it's going to add the device. So let's move into the next part, which is adding our Festo SMS series device. So for this, we need to go to the website and download the EDS file. So right now I'm going to go to close this particular one. I'm going to, in my case, I would simply come into here, copy, and I would paste the name in, and then as I zoom out a little bit, go to the software, and then we have the IODD files. So if you expand this at the time of this video, we have the version 1.27, which also includes older versions. So when you download this using this link, then you get into my project directory. And when you expand the unzipped, because you need to unzip the file, you have all series or all controllers or all drives. And in my case, we're using this particular model here. This is my IODD file, and this is what you want to register. So I'm going to register this. So we have a couple of options. Typically, the EDS hardware installation is included right here in this drop-down menu. Alternatively, if you type in EDS, you'll come up to the installation. You would open this up. And you would simply add, and then you would find that project, You select the path, and this is the file. So then you would continue and say next, 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 next. So I'm going to ignore this right now. And if I go back to my project, because I've already registered, I should be able to right click on the IO link and say new module. Again, go to the search window, ELGS. Type code or product code is 602. So we have this right here. Before I add this, I'm going to show you, actually, I'll just keep going. So I'm going to say create. And at this point we need to configure. So I'm going to call this channel 0, IOL1. So I'm on IO link 1 and I'm on channel 0. And we need to configure the module definition. So we have 1.1. We can say compatible. I like to say, well, this is a whole other topic about compatible or disable. I'm just going to disable keying for right now. You can do compatible, no problem. ADC is automatic device configuration. We're not going to discuss this in this video. We're going to do that in another video, or I am. And so when we do this, then backup restore is activated, data connection is good. So we accept this definition change. And we look at other problems or configuration, and we don't have anything we need to do at this point anyway. And we have configuration parameters. These are the parameters that will be sent for data storage. We have all parameters, which when you're online you can see this, and so on and so forth. So we accept this, we close it. So now we have a device and everything set up. And if you're uncertain about the firmware, you can go to your RS links, which is not open right now. So I'm going to say communication, start my communication. And I've already configured in RS links the connection to my Ethernet port on my computer. I'm selecting the PLC. I'm going to say set path, close it at this point, and then I'm going to do I'm going to save the project, and now I should be able to go to RS links because it's open. So we can look under RS who, expand this. Wait a second for a view of what's there or what's not. So there's my IO link channel. If you go to device properties, you can see here that I'm using firmware 2.012. It's very important for this project because the add-on profile needs to match that. The PLC device properties, we have version 35.013, which means the 35 software is active. And from a module configuration, we've got 117, 192, 168, 117 is our PLC project. 130 is our IO-Link master. So if you don't have the EDS file for this, you could always upload the EDS file simply by doing that. It'll register it. Same thing goes for the PLC. I'm going to close this now. So as we know, we did the 130 here, and so on and so forth. So now we should be able to download and get to a point where at least we'll see if we're at a point where we have any errors or anything. So I'm simply going to do download. Okay, downloading's done. We're putting it into run mode, and we can analyze the information by double clicking the 8OL. And under the connection, we can see that we're running without any problems. If we open up our ELGS ball screw we can see that the IO-Link master is communicating to this, and we have a status of running connection. We have no major faults. Everything seems to be working okay. We can see the parameters, which is great, and take note of this information along the bottom here. If you want to modify any of these parameters, the connection must be inhibited. So we click apply, yes, and then we can go back to the configuration and we'll see that we have to either upload or use the project. So I'm going to upload from the device and apply so that we're correlated with the device and the IO-Link master. And we'll see here that we have parameters for speed in and out, positions of start pressing force, and position out, intermediate position, so on and so forth. And additionally, when you're in the inhibit mode, you can execute commands and so on and so forth. So I'm going to re-inhibit this or uninhibit this, apply, yes. So at this point, we're up and running. So now we want to add some code. And one other thing, I'm going to open the properties here, going back to the fact that we're supposed to be on the version. So this 8IOL M12 is using 2.012. We go to the profile information. We can see that we're using this software 20122. And we're going to close this and go offline now. And we're going to look at the process data. So we have nothing here, of course, because we haven't put any code in. If you go to the controller tags and you look at the grayed out information, the grayed out information is always the system tags. So we have channel 0 data, process data, we have input data, process data in. So without doing any work, we have these bits. And what I'm going to do is I'm going to quickly add these bits to some code. And I'll create a routine for this. And at the same time, what I'm going to do is the IO-Link master, I'm going to add some status. So we have the IO-Link master status bits, and we have the channel 0 status bits. So I'm going to add all these to a routine. So right click, say new routine. I'm going to give it a name. I'm going to use the name I just wrote in here. And we're going to start writing code. Okay, I've done some offline code and I've added some text. And what I've done here is I've also, for the inputs, for the input data, so if I go back to the controller, I've added these descriptions myself from the user manual so that it's a little more friendly for the user. We've got intermediate position, we've got state device, which means that it's ready for operation, the Festo ELGS, and then we've got status of the fact that it's moving, and then we've got a state in or out. And if both these inputs are on together, that means that there's a fault existing. And then for the outputs, it's pretty basic. We've got a quit error, and then we've got to move to intermediate, move to out, move to in. And then for our 8IOL master from Rockwell or from Allen Bradley, we've got some status bits that are important before you can run into or do something. And in the main routine, we of course need to add a jump routine, so we need to add this. So we're going to jump to the process data. So if I just do a download now, just to prove out what we've done so far. And we'll get an idea what the device can do. And we're going to go into run mode now. And we'll go back to this process data. And I'm just going to move this window around. Okay, so here's the process data. And here's a picture of my hardware. So we've got a red LED on, and we've got the IO-Link master. It's yellow over here, and we're flashing for Ethernet status. So at this point, as I said, the two bits are both on. That means it's default. So the first thing we can do is toggle this bit. And when you toggle this bit, either it's just Control T, toggle bit. Same thing. Now the device is ready for operation. And the way that the function or the design of the SMS series or the ELGS is arranged is that the very first time you turn something on and do a movement, the device will execute a home. So move out, it actually did a little skip backwards first, and then it moved forward because it was actually homing first and then moving. So the bit has to be on while you're moving, otherwise it doesn't finish, and when you're finished it gives you the status out. So if I turn this bit off and I go move in, and I turn it off before it's finished, we'll see that it's not at state in, it's stopped in the midstream, and if we want to finish it, then we leave the bit on until we get it done. Likewise, we move to an intermediate, which is in the middle. That's what I programmed when we were looking at the configuration. And quite simply, the ELGS or the SMS is already functioning. The next thing we're going to talk about is the data storage. And if we go back, just going to close a couple of routines here. If we go back to the add-on profile for the ELGS. And we go to the configuration. As I said earlier, these are the parameters that are sent over data storage. And if we want to modify these in the project, there's a few options. There is the fact that I showed you earlier, we need to inhibit the module. Yes, accept this. Go to the configuration. So we're at the intermediate position, which is out here. Intermediate position, if I change this to 60, hit enter, I apply, and we go back and uninhibit the module. And now I simply make it go to the intermediate position again. It's just moved to the new target position, which was forward. So the previous one was 45 millimeters, now we're at 60 millimeters. And that's how we modify the parameters in the configuration. The next step is going to be explicit messaging, where we modify the parameters. For this, we need to open up the user manual for the Rockwell. I'm going to close the webcam viewer temporarily, expand this just a little bigger, and let's go offline. So we open up the user manual and we go to chapter 6. Again, this is the 5032 UM001 November 2024. I'm on page 94, and we're talking about using explicit messaging. Explicit messaging in the 5032 8IL is very different from, well, not very different, it's slightly different from the 1732E 8IL and the 1734 4IL. And there's one thing that most people miss when they're reading is this this right here. The connected checkbox must be selected when you're doing a write to a parameter. And we'll show this explicitly soon. There are some vendor-specific, so these are vendor-specific services for IO-Link service parameter objects. So this is something that Rockwell has functional, but additionally there are the specification for IO-Link himself, and the IO-Link specification, those can actually be used without any problems and are sometimes a little more user-friendly than this particular one, because with IO-Link we have Little Endian and Big Endian. The controllers in Big Endian, the IO-Link devices are Little Endian, and when you have floating point or other device data types that are unique, it can be a little bit of a pain to convert all that information into the PLC. So to use the IO-Link specification, it's going to be a little bit easier, and I'll show this a little bit. So the first thing we'll show for an example is using the vendor-specific codes. So we're going to add a routine, and we're going to set it up so that we can modify the speed in parameter, this 0 through 100%, or this, sorry, 10% to 100%. And in order to understand what to do with this, we need to open up the user manual for the ELGS. So if we navigate to the web page, we go to the user documentation, and we will download the operating instructions. And each individual type of integrated access has a user manual, like ELGC, ELGS, but the IO-Link specification is included in this EMCS-ST. So this particular product right here, this 2024-08, is the latest. So we'll download this. So this is the device, and we're just going to download this. Okay, so I have this opened offline, and then if we go back to the website, the other product I would like you to download is this application note, IO-Link Interface Description Simplified Motion Series, and this is the latest, so we'll just click on that and download. So I'm going to open this offline. So this second document looks like this, and within the application note we talked about parameters and everything that we're doing right now. So in the operating instruction manual, in section 15, which is the IO-Link, under IO-Link parameters, we have a description about all IO-Link parameters for that device, for the SMS series or the ELGS. And if we scroll, we get to a point where we find this IO-Link speed in value, and it's using this index, and this is the description or meaning about it. This is the data type. So data type is unsigned integer 8. The name is the speed in, and the index and subindex is basically 100 hex.0. And we need this information for the explicit message that we're going to be using. If we go to the other document, the application note, on section 9, I think it is, page 9, there, here we go. The same thing is described. We've got the speed in, default, tells you whether it's read or write, and the format, byte length. So we need all that information along with the 8IOL, and then we're going to set up an explicit message as we have talked about right here, or as as it explains right here. And I'm going to do this right now. So I'm going to add another routine. The first thing we need to do is add a message instruction, which we go to the input output, go to message, click on it, and I'm just going to zoom in a little bit here. And the first thing I want to do here is give it a name to instantiate it. So my naming is going to be as specific as possible, so the IOL1 channel 0, so I would use that for this device. If we go to the user manual, we're setting up a class 10B, so 10B, service 32, because we have service 32 as the service code, and then the 0 times 100 underscore 0, that is stemmed from the description here being 100 underscore 0, which is the index and subindex. And underscore R for read, it would be a W for write, and then message. So I'm going to right click and say new and create. And at this point, we click on the little dots to go configure. The first thing we need to do is pick the path, and we're going to pick the device. At this point, we are not using connected because we're doing a read. Later, we will turn on the write, or I mean the connected. And then we're going to configure the message instruction. So the service is 32, class is 10B, the instance is 100, but this is actually represented in decimal, so if we go back to the 256 0, so this is 256 because that's decimal, and 0 is the attribute. We have no source element because we're not writing any data, so source element is 0, and then we need a tag to write the information to. And keeping with my naming convention, I'm going to call it everything like that. I'm going to call it the raw data. And the data type is unsigned integer. So I'm going to give this a unsigned integer. I'm going to say create. And then I'm going to use that. I'm going to click on apply and hit OK. And we need to be able to activate this off and on, and I'm going to add a bit for this. So I'm going to add a bit, favorites, give a click, and read enable, new, default. So there is our value, and I am going to download this as soon as I add a call from the main routine, and open up the main routine, and I would do this. If you don't know how to do this, I always put a rung and then I just type in JSR, enter, and then I go and I pick the device, and at this point I can do a download. And we're going to put it back into run mode. So we'll open up two windows. We'll open up the configuration window so we can see what the value is. And we can modify the value, and then we'll read the value with the message instruction. And while this is opening, the the user manual shows you that 1 equals 10%, 10 equals 100%. So right now under configuration, we have a value of 100%. So if we execute this instruction, Control T, we get it done. And I need to go to the controller tags and look at the raw value under monitor, and we have a value of 10. So we can activate a watch window. There we go. So I'll close this, move this down a little bit, and turn this off. And in order to modify this value when you don't have any code, again, we go to connection, we have to inhibit the module, apply, yes, and we go to the speed in, we modify it to, let's say, go 30%, apply, we re-enable the connection, and if I toggle this, you'll see here that the controller or the raw data is now a 3. And if we go to the process data and we move in and out, so this was for speed in, so move out nice and fast. Turn the webcam viewer back on, and if I move in now, the axis is moving much slower because we've lowered the speed from 100 down to, I think it was 30%. And again, that's how we do a read. And we've already set up the message instruction. So now we're going to go offline. We'll save. Make sure you save all the values. I'm going to go offline. I'm going to close the webcam again. And we're going to add a write value, a write message. Okay, so we go to the input output again after we add a rung. Input output, and we can click and drag if you want. Same thing. And we're going to add a tag, which is identical to this one, except I have a W in here. I'm going to instantiate this or add this tag. It'll do it as a default. And the configuration is opened by the little dots again. We go to communication, we pick the ELGS. Again, I'm going to leave the connection tab off so that we encounter an error and we show you that it doesn't work this way. So I'm going to leave that for now, but I'm going to continue to configure the thing. And if we go to the user manuals, the difference between read and write is 32 and 33 for the service. Everything else is the same. And so in this case, this is going to be a 33. This is going to be a 10B again. And again, 256 decimal is 100 hex. The main difference between the read and the write is that you need a source element in order to write. So we can go and we can say new tag. We'll give it a source, and we want it to be a cint. The cint is because it's 8 bits or 1 byte. In the last read, I used it as an integer, but that doesn't really matter. It's when you're doing a write that it needs to be the right size. And I'm going to say create, and now I'm going to paste this tag into there. The source length is 1 byte. There is no destination element required. We hit apply. Okay, and Again, I want to be able to trigger the message instruction. So I'm going to add a bit again and another bit. Say new bool. So, and what I want to do is I want to add another instruction, a move instruction, just so we have it outside. I'm going to say move and go back to process data. Sorry. We want the bit here to be this source value here. So double click, and I'm just going to write to itself. Right now it's 0, so that I don't have to go to the tags. Alternatively, we could add it down here. So I'm going to do that. Right now it's a 0, and same thing. And basically, I'm going to do a download. Okay, we're going back into run mode. And again, if I do a Control T and read it, we're entering, or we're seeing a 3. And right now, if I enter a 4, value of 4 here, and I toggle this, we'll see that we get an error. And error processing connected ready to service with the extended error code, so forth. So you can troubleshoot this and so on and so forth and whatnot. If you remember, in the earlier stages, I talked about the fact that messages should have a connection checkbox selected. And this is likely what the problem is, I'm hoping. And so can't modify instruction when it's live, so I'm going to turn this off, go back to the configuration, turn on connected. We do not need cache connections. I'm going to say apply. Okay, hit OK. And now I'm going to toggle the bit again, and lo and behold, we have it done. And if I go and I do a read now, we'll see that we have a match. So the values are matching. And let's just see what this does now to everything else in the project. So I'm going to rearrange the screens again. Okay, so I'm going to go to the process data. I'm going to move the device out and then in. You can see how fast it is. And if I go back to the speed in and I modify the value to a 10, Control T, Control T. So we've set it to 10, we've confirmed it was a 10, we go back to process data, we move out again, and we move in. Now it's going at the correct velocity. And now let's look at the module properties. We'll see here that the module properties are showing that it's 30%. That's because this add-on profile does not synchronize itself with the device until you've done this yourself. So in order to synchronize this particular controller parameters page, again, you need to go and inhibit the module and go back to the configuration. The first thing it's going to do is, hey, what are we supposed to use? Does not match. So we say use device, and we'll see here that's what we have written. Hit apply. Now, as a test, I've not tried this before. I'm going to write a value of 8 right now, which is 80%. Control T. Control T, it means it's confirmed. I'm going to go back here. If I correlate, it again tells me, and then it moves it. But only when we're in the inhibited state does it do this. So it's important to understand all that. Again, I'll show you that what we just did there, only when you are in inhibited state does it update this. So yes, the values changed in the device because that's what these are doing, is they're writing to the device. and here they're not. It still says 80%. So that's this step. Now for the last step, which is the data storage, let's talk about this. And before we talk about this, we need to look at the user manuals. So in particular, the application note, if we go to the home page and we go to the data storage section 4, we can read this information. It shows you here that these tags with the indexes are the tags that are part of the data storage, and I've already showed you that these parameters right here are part of the parameter data storage. They match up to this. There's some really important things that have to be used as a guideline in order for the data storage and the backup restore to work properly. The first thing is that the ID, device ID of both devices. So device 1 is the original device, device 2 would be the replacement device. Both must be the same. In our case, we're using a 602, which we showed earlier. You could go to the General tab, Connection tab, where is it? Device Info. 602 is the device ID. So that device ID has to be the same. I haven't talked about it earlier, but I'm using the latest firmware, 1906.16. That's also important. Hardware version is the latest, Rev 4. But the device ID must be the same. And then something very, very important is that the value of the end position out. So go back to the configuration. End position out. That is this right here. So this, hang on. So the end position out, which is the stroke position for moving it out all the way. That value in the original device, the device that's active, must not be greater than the maximum position of the new device. The maximum position is set through a reference run. So let's just see what happens here. So I'm online right now, and I'm going to execute a movement. So I'm going to inhibit the module. I'm going to go to the parameters. I'm going to scroll, and there is a execute reference movement here. Hopefully you can see that. It's this right here, and I'm going to execute this. I'm going to say yes, and right now it's executing a reference movement, and it's going end to end, and it's determining its stroke. And when it's finished, the values for start position and whatnot are going to be updated, which is what happened right here. I don't know if you noticed that, but the values have just been changed. So we go to the configuration, use the device. Before I say that, see how its intermediate position is 60. So I'm going to say use device. So after it does a reference run, it determines these values. So I'm going to hit save. Say yes. So this value, 104.26 millimeters, must be, according to this, smaller than what the device replacement is. So when you get a device from manufacturing, we don't really know what that device value is going to be. And if you find that you connect the device and it's not replacing it, then it's going to keep the old values. This is because of what we just showed you with the reference run. it determines the tolerances. And if the tolerances are different at manufacturing, which is, you know, allowed, they'll have a problem. So in my project, I am going to set the end position out to 103. So 103.00. And because that value is changing, if you look at the laws of what things are, the start position press also has to be the same way. So if I change this right now and I just say apply, it's going to say it's out of range because I didn't change this one as well. So 103, that's out of range, and it should still fault. Yeah, because this one, you can't have an intermediate position beyond the end position out. So I'm going to put them all at 1.3 or 103, hit apply, and then I'm going to change this to a 50, so that is more or less the middle of the axis. And then before I do anything else, I need to activate these stored parameters. So in the parameters section, the store parameters is under parameter storage. So this right here, right below it, sorry, the store parameters, that button there is what activates the store parameters. So I'm going to activate this, say yes, and now the IO-Link master has these parameters that are being stored. And now I'm going to put this back into action. I'm going to say yes, and wrong one. So now it's back in action, and it moved in because I had this bit left on. And basically, it'll move in and out. So it's moving in and out. You can see how they're fast and so on and so forth. And those are stored. So what I'm going to do right now is I'm going to show you I have a device that is manufacturing default offline. So I have another IO-Link master. I have a CDSU, which is a Festo IO-Link master, and I'm going to connect to a different device. Okay, and this IO-Link master basically is connected to this. We can see here that we have the same ID, 602, and I'm just going to go to the specialist role, scroll, and all I want to do here is a restore factory default. And what's happening right now is that particular device is cycling, and I don't need this IO-Link master tool anymore because it's resetting itself. The idea here is, well, actually, give me one more second. I'm going to show you that after reset, not the firmware, the specialist, that connect, by default, the values of speed, for example, are 10%, and the values of end position out are 104.25. So the 104.25 has to be larger than what is in the device right now, which we set for 103. So 10% speed, 104.25, keep these in mind. I'm going to go back to the other. Okay, so now I'm going to connect the other IO-Link device. Give me 1 second. Going to physically disconnect the cable on the IO-Link port. And So we're yellow, and that's what happened to the device. And Control T. If I do a move out, you see here, that is not 10% speed. So if I do a move out, that's the same level as it was before. So I've done a replacement, and with the manufacturing default, and everything is working as it was on the previous device. And that is what is going to be the gist of the data storage. I'm trying to think if there's anything else that's important. Again, we have the configuration. It remains the same. The speed in and out, and so on and so forth. And everything's going to work the way it was. I think that's about it. So I think we'll call it a day on this project, and that is how the SMS series ELGS, in this particular case, works with the 8IL. We've talked about how the connected message must be connected. We don't use cached. If you look at the user manual for the Rockwell, it's all in there, and everything else is pretty straightforward. In the sample code that I'm going to leave as a link in this YouTube video below, just expand the information below the video, I will add a couple of other routines, because the message instructions can be a little complicated. The specification of SIP Networks Library Volume 7C has a lot of other things, and hopefully you've subscribed to it. Anyway, the literature there discusses more, so I'm going to add some message instructions that talk about a few other things. So I think I will set up some messages for position end, for position actual, for referencing, storing of parameters, the event codes, and some system commands for doing a factory reset. And that's it. Thanks for your time. Hopefully this is helping you.